Morning. Thought I'd just go ahead and do a quick video on the docking seal station here assembly, and I can show a quick animation of how the components will work when they're in operation. So this is pretty basic. This is the seal housing right here. Outside of it, we've got 4.5-inch pipe, a 4-inch NPT threaded nipple there, 4-inch NP threaded flanges there and there. In between the two flanges, we have our gland seal housing, and that has a 1/2-inch NPT outlet for the fluid on the side of that. That's made out of high impact PVC plastic. Then right here we have another 4-inch NPT nipple, got a high pressure 4-inch NPT cap. And as we move towards the top here, over here on the right is a capacitive, normally closed, or NPN sensor that will sense the docking guide rod. When it reaches the surface, it'll enter into this part of the nipple. That capacitive sensor will pick it up and stop the unit and start the fluid discharge cycle on the controller. This is a heavy, high pressure threaded coupling. I just used a heavy coupling because we're going to weld it to the bottom of that 3/4-inch adapter plate. And incidentally, that adapter plate is where the baler will bolt on to the 4.5-inch center hole pattern there, and that I believe should be tapped 5/8 11 taps. Here we have our 3/4-inch seal housing, which will house the dynamic high-speed packing gland seals, and a cap, and there's a spring in there that I'll show in another view. This would represent the nylon coated cable, where that's coming through the top of that location there. And of course below that we have our canister. There is the canister right there. And of course your fluid canister, the new seal nose, that'll also be made out of high impact plastic, PVC. Then we have our Schedule 40 PVC canister pipe. That's the vent. We have our check valve adapter, and of course strainer on the bottom. Okay, so that's the basics of it. Now we'll go to the half section view here and look at the components on the inside. I'll do a quick animation here so you can see it in action. In fact, I'm going to do the animation first. It'll explain itself. So right now the canister is up whole and docked, ready to discharge or evacuate the fluid. And the guide rod has reached the inside of the 2-inch steel nipple there, and it's in front of the capacitive sensor. So what I'm going to do right now is do a quick animation, just driving the constraints themselves. I haven't had time to do a full animation yet, so I'm doing this on the fly so that you can see what I've got drawn up here, as I'm still in the process of labeling and dimensioning everything out. And I actually need to get over to Odessa and do some work there this morning. Okay, so we accelerate slowly, and the compression spring is pushing the canister and the rod seal nose, out of the gland seal housing, and it's replacing itself into the gland seal housing. So now the rod compression sleeve has the fluid outlet sealed here, maintaining the composure and shape of the seals. And now we are able to slip out of this looser fit, out of the guide sleeve, and head on down the well bore. And I'll show that right now by animating this next constraint. So we'll drive this next one. And now we're heading back down the well bore. And I'm going to bring it back up and let you see the whole process again. It's pretty straightforward. I think it'll work a lot better. The spring is centered. It's an 8-inch compression spring, has a 100-pound full compressed load capacity. I think that should work quite well for us. Okay, so what we'll do is I'm going to zoom in a little closer here, and we're going to bring the canister and the guide rod back up the hole and seat it into the seal docking station. So the first process happens here. So the stainless steel 3/4 inch solid rod that's threaded into the seal nose is guided into the guide sleeve, compression guide sleeve, and now it's reached, and it's also guided up here towards the top. So now we're straight, and we reach the bottom of the compression sleeve here, and this is all going to happen in a few seconds, of course, when it's coming up. Once it reaches this point, I'll drive the next constraint. Now it compresses, so the speed of the uphole return is being slowed and absorbed in the shock here, in the compression sleeve, and it's able to make a smooth transition into the seal gland housing here. So now the fluid's discharged. It's either evacuated through the suction line via the pump, or if there's enough gas pressure, then gas pressure is equalized through the vent on the canister, and the fluid can be pushed out using the gas pressure, and that's picked up on a separate sensor on the controller. So then to return back down the well bore, we go for a slow acceleration. So we ramp up very slowly when we allow the compression spring to push the canister out together, so these stay together as they're coming out. And now the compression sleeve has replaced the itself into the seal, maintaining the composure and shape of the O-ring seals. And now we're into a slip fit where the canister can easily slide out of that compression sleeve right there. And of course from that point it would just continue back down the hole again. Sorry this is so slow, but I'm doing it on the fly. I'll actually do an animation of the whole thing when we're happy with this. So take a look at the video and let me know your thoughts, and I'll continue to dimension things out and get those to you as well. But I thought this would be a good place to start for conversation and determining that we want to proceed with this method. So thanks for watching. Let me know your thoughts. Have a great day.